Hello again, and welcome to our video for section 2 of DMA 20, where we're going to learn how to multiply fractions. In this section, we're going to cover the rules on how to multiply fractions, and then we're going to look at a couple of different methods that help us simplify fractions before we multiply. The first is going to be the cross-canceling common factors method, and then a prime factorization method. After that, we'll look at how to work with exponents in fractions, and then finally finding the area of a triangle. To multiply two fractions, simply multiply the numerators and then multiply the denominators, and if possible, simplify the result. So, we're going to jump right into some examples. Our first example is 1/6 times 1/4. Here, we multiply across the top. 1 times 1, we'll get 1. And then multiply across the bottom. 6 times 4 is going to be 24. And in this solution, we have no common factors, so there's no need to simplify. Our second example is -7/8 times 3/5. Remember, then when we have two sets of numbers, and a set of numbers in parentheses and another number outside with no operation, we can imply that to be multiplication. So we can think that there's a little time sign between these two numbers. Okay, now remember your sign rules from DMA 10. This is a negative times a positive. I always like to write the sign first so I don't forget to later. I know that a negative times a positive is going to be a negative, so I'll go ahead and write that sign in and then put in my fraction bar. Now when I multiply across the top, I get 7 times 3, which is 21, and then 8 times 5, which is 40, and again, no common factors, so no need to simplify. Our third example is a little different. I have 1/2 times 3, so I have a fraction and a whole number. When working with fractions, I find it easiest to change everything into a fraction and then follow the rules for whatever operation you're doing. So I'm going to rewrite this as 1/2 times 3/1. Okay, remember I can write any whole number as a fraction by writing it over 1, because 3 divided by 1 is still 3. I haven't changed anything here. So I represented that whole number as a fraction by writing it over 1. Now I multiply across the top. 3 times 1 is 3, and 2 times 1 is 2. So I get 3/2, and I'm just going to leave that as an improper fraction. Now we're going to look at some methods to help us simplify fractions before we even start multiplying. Now keep in mind that these methods only work for multiplication. They won't work for addition and subtraction of fractions, and you'll see in the next video how they will work for division, but only after another step takes place. So for now, just remember that these will only work with multiplication of fractions. In this first example, I have 5/8 times 1/10. I could easily just, I'm going to write this out to the side, multiply across the top and get 5, and then multiply across the bottom and get 80, but that's a fraction that I have to simplify. I notice that there's a common factor between the top and the bottom, which is 5, so I divide the top by 5, divide the bottom by 5. 5 divided by 5 is 1, and then 80 divided by 5 is 16. So after I multiplied, I had to remember to simplify the common factors out. Now we can actually take the common factors out first before we multiply to avoid getting big numbers like 80 in there, and that kind of eliminates that simplification step at the end. And I'll show you how to do that now. To do this, we have to look for a common factor between the top and the bottom of two different fractions, and we can divide them out before we multiply. So here, I notice that there's a common factor between 5 and 10. Okay, the common factor here is 5. So I'm going to go ahead and divide out that common factor first. I'm going to divide 5 by 5 and replace that with a 1. and divide 10 by 5 and replace that with a 2. Okay, so now if I were to rewrite this, you don't have to rewrite this, but sometimes if it helps to keep things from looking messy, this would look like 1/8 times 1/2 after I factored out those common factors. Now, I multiply across the top. 1 times 1 will give me 1. And then multiply across the bottom. 8 times 2 will give me 16. And I got the same answer as before, but I didn't have to remember to look for those common factors at the end. Now, in the second example, we have 3 numbers being multiplied together. We've got negative 2/3, 9/14, and negative 7/10. Again, I'm going to apply my sign rules first so I don't forget to do it later. A negative times a positive will be a negative, and then a negative times another negative will be a positive. So just as a reminder, I'm going to write myself a little positive sign here to remember that my answer is going to be positive because I figured out those signs. Now I'm going to look for common factors between the top and the bottom of fractions. I see one with the 2 and the 10, right? It's good to note that these don't have to be right next to each other. So 2 and 10 are both divisible by 2. So I'm going to divide a 2 out on the top and get 1, and a 2 out on the bottom over here and get 5. I see another common factor between 9 and 3. They're both divisible by 3. So I'll divide 3 by 3 and get 1, and divide 9 by 3 and get 3. The last common factor that I see is between the 14 and the 7, both divisible by 7. So I divide 14 by 7 and get 2, and 7 divided by 7 is going to give me 1. And I'm going to go ahead and rewrite this one again. I now have 1 over 1 times 3 over 2 times 1 over 5. This is nice because now I'm working with much smaller numbers, and it prevents me from getting really large numerators or denominators. I multiply across the top. 1 times 3 is 3, times another 1 is still 3. Then multiply across the bottom. 1 times 2 is 2, times 5 will give me 10. I get 3/10 as my answer. The next method that we're going to look at is the prime factorization method. People like this because it's a little less messy than the method that I just showed you, but it does require a little bit more work to factor everything to its prime composites. Okay, I'm going to use the same 2 examples that we used last time. So in this instance, I'm going to multiply all the numerators and all the denominators to their prime factorization, and then cancel out any common factors that might arise. So the tops of these fractions are both prime. 5 won't factor into anything, nor will 1. So I just am left with 5 times 1, nothing to factor. But on the bottom, I have to factor out all the different, all the primes of 8 and 10. 8 factored down to primes, you can use factor trees if you need to, is 2 times 2 times 2, and then 10 factored into primes is going to be 2 times 5. Okay, so everything's factored to primes, and then I'm going to cancel out my common factors. There's a 5 on the top and the 5 on the bottom, so I'll cancel both of those out, and then multiply the tops and bottoms. All that's left in the top is 1, and on the bottom 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So I get the same answer with this method, 1/16. I'm going to do the same thing with our second example. Remember, the sign of this answer is going to be positive, so I'll jot that down here so I don't forget. And now I have to factor all these to primes. So 2 is prime, so I'm just going to copy that. 9 factored to primes is 3 times 3. And then 7 is prime, so I just get to copy that down. Now factoring the bottom, 3 is prime, so I'll copy it. 14 factored is going to be 2 times 7. And then 10 factored is going to be 2 times 5. Now every time I see a common factor between the top and the bottom, I'll cancel it out. So the 2 on the top will cancel with 1, 2 on the bottom. A 3 on the top will cancel with 1, 3 on the bottom. And then the 7 will also cancel with the 7 on the bottom. So I'm left with only a 3 on the top and a 2 and a 5 on the bottom. So when I multiply that out, I'm left with 3 over 10. And remember that this answer is positive. Now we'll work with some exponents and fractions. Remember, this tiny number is the power or the exponent, and the number that it's next to is called the base. So the base is going to be repeated several times with multiplication, and the exponent tells us how many times we're going to repeat it. Okay, when you're first starting with exponents, I do recommend that you write out the full expansion before you try to multiply so you don't miss any steps. So in this example, that we have 1/4 to the third power, or you may hear that as 1/3 cubed. Third and cubed mean the same thing. When we expand this, we've got 1/4 times itself 3 times because our exponent was 3. So 1/4 times 1/4 times 1/4. That's 1/4 cubed, or 1/4 3 times. Okay? I multiply across the top. 1 times 1 times 1 is just 1. And then I multiply across the bottom. 4 times 4 is 16. And then 16 times 4 is going to be 64. Now remember our exponent rules. When I have a negative on the inside of my parentheses with my exponents, I'm going to have to repeat this negative sign every time I repeat my base. When I have it on the outside, it just gets carried over once, and I repeat just what's in the parentheses here, the positive 2/3. So let's see what that looks like when I expand these two. First, we're going to do negative 2/3 twice, because the exponent is 2. So since the negative's on the inside, I carry it both times. Negative 2/3, times another negative 2/3. The negative comes with me both times. So let's multiply across the top. A negative times a negative is going to be a positive, right? So my answer is going to be positive. 2 times 2 will be 4. And then 3 times 3 will be 9. So I get a positive 4/9 here. Let's see what happens in this scenario. When the negative is outside the parentheses, I just carry over that one negative sign. And remember, when I expand my exponents, I'm only expanding what's inside. So I have a positive 2/3 once and a positive 2/3 a second time because my exponent was 2. So my answer, that negative again, is going to follow me to the front. I've got 2 times 2, which is 4. Then 3 times 3 is 9. So in this scenario, I get a negative 4/9. So depending if that negative is on the inside or on the outside, it may change the sign of your result. Now let's look at how to find the area of a triangle. Now in DMA 20, this is one of the formulas that you will have to have memorized. So make sure that you get this down in your notes. You are also responsible for the formulas that you had to memorize in DMA 10. So those would be things like the area and perimeter of a square, area and perimeter of a rectangle, the perimeter of a rectangle, as well as the Pythagorean theorem. So if you don't remember those formulas, check in your DMA 10 textbook or the ebook that's available to you in WebAssign, or visit this YouTube channel and visit the geometry videos for DMA 10, so you make sure that you'll have those formulas memorized too, because you will be using them in your work and on your test. Okay, so the area of a triangle is 1/2 the base times the height. And we can write that two ways. You may see it with a fraction like this, 1/2 times the base times the height, or this is kind of how I prefer it, base times height divided by 2. Okay, I like this way better because instead of multiplying by a fraction, writing it like this turns it into a division problem, which is how I like it. But either of these will work, so use the one that you're most comfortable with. Next, let's talk about how we find the height of a triangle. The technical definition for the height of the triangle is if the length from the base, which would be the bottom, to the opposite point of the triangle that makes a 90-degree angle with the base, or a right angle. So if this is the base of this triangle here, the line that will make a right angle from the base and go to the opposite point would be right here in the middle. That makes that L, that 90-degree angle that we sometimes represent with that square. So the height here would be inside the triangle. In the second triangle, this is a right triangle. Okay, so that means if the base is here, right triangles have a 90-degree angle as one of their angles. So the height in this triangle would actually be the side. In our third triangle, this is an obtuse triangle because it has this big angle here at the bottom. If we had labeled this the base here, the line that makes a 90-degree angle with the base and goes to this opposite point over here is actually outside the triangle. If we were to extend the base like this, the height would actually be measured outside of the triangle. That makes that 90-degree angle here from the base to the opposite point. So depending on what type of triangle you're using and where the base is located, we could have the height inside our triangle, one of the sides of the triangle, or in the case of an obtuse triangle, on the outside of the triangle. Lastly, we're going to look at an application problem that involves finding the area of a triangle. So a design for a bathroom tile is shown below. Find the amount of area on this tile that is shaded. So we don't want the entire area of the square here, we just want the purple parts. So if you'll notice, this shaded area is the composite of 4 different right triangles. We've got a right triangle here, a right triangle here, a right triangle here, and then a fourth one here. Okay, we can find the area for one of these triangles using that formula that we just found. Okay, and since all these triangles are the same size in this tile, once we find that area, we can just multiply it by the 1, 2, 3, 4 triangles that we have, and then we'll have the area of all the purple region here. So let's recall what that formula was. Area equals, I'm going to write it as base times height divided by 2. Okay, the base of this triangle is the bottom here. We'll call that B. And the height is the side here, because this is a right triangle. We can use the side for a height. So when we plug those bases and the heights into our area problem, we get 3 times 3 divided by 2. And when we multiply, we get 3 times 3 is 9 divided by 2. 9 over 2. And for now, we're going to leave that as an improper fraction. But remember, I have 4 of these triangles, not just one, so I have to multiply this by the number 4. Okay? Since I have one fraction, I'm not going to write the number 4 as a whole, but express it as a fraction as 4 over 1. So I get 9/2 times 4, or 4 over 1. I'm going to use that cross-canceling method. I notice that there's a common factor between 2 and 4. That common factor is 2. So when I divide 2 by 2, I get 1. And when I divide 4 by 2, I get 2. And now I can multiply. 9 times 2 is going to be 18 over 1 on the bottom. 1 times 1 is 1. So we would just express this as the whole number 18. And let's remember a little bit about labels. Okay, the sides of these triangles were measured in inches. Okay, so we know that our area is going to be inches, but since we're dealing with area, we'll call it square inches or inches squared. Area is always going to be in a square unit, so whether it's square inches, square feet, square meters, square centimeters, make sure you always keep your units squared. So that's it for section 2 of DMA 20. In this video we learned how to multiply fractions. We learned about the cross-canceling common factors method for simplification. We learned about the prime factorization method for simplification, explored exponents and fractions, and lastly, looked at the area of a triangle and some applications. In our next video, we'll be discussing section 3, dividing fractions.